I will let the panelists all introduce themselves. My name is Adam Honore. I am responsible for data product management at Chicago Mercantile Exchange. It is my second stint at an exchange. And if you want to know more about me, you can Google my name or as you see fit.
Good afternoon. I'm Jason Cornez. I'm the Chief Technology Officer at RavenPack. And as Adam just asked me, I've been there since the beginning. Prior to that, I had experience in Silicon Valley, and I'm a technology guy with a computer degree from MIT.
All right, thank you. Good afternoon. My name is Stuart Kozola. I'm the head of product marketing for the computational finance area at the MathWorks. You guys probably know that as the MATLAB company. Not too many people know the name of our actual company. I've been doing that for around 10 years. Before that, I was actually doing statistics, managing the statistics, optimization, neural network, kind of the whole thing that's called data science today for the company. So now I'm doing both data science with the bent towards our finance area.
My name is Thani Sokka. Good afternoon. I'm with Dow Jones. I'm the head of technology for what we refer to as our professional information business. As you know, Dow Jones has a consumer arm as well as a enterprise or professional arm as well. So I head up the technology for that group, and recently launched a new product called DNA, Data News Analytics. It's all about offering up our wealth of content for the purposes of doing things like machine learning and so forth to derive additional data sets and insights. I've been with Dow Jones for a little over 2 years. Before that, I did some time at Google, Oracle, Booz Allen, Thomson Financial, well, when it was called Thomson Financial before Reuters acquired it, and MicroStrategy and a few other companies.
So I'm not going to wait until 10 minutes until the end, or 5 minutes or 30 seconds as some people are wont to do. If you have a question, I mean, we're here for your amusement and pleasure, so raise your hand. There are mics in the back of the room, and they will be watching. Feel free to interrupt the flow, see if you can get us off our game or whatever, like to consider it a challenge. Drinking game, however you want to do it. But by all means, if there's a thread that you want to pull on a little bit, raise your hand and somebody will bring a mic to you, and we'll keep this as interactive as possible. I'm going to start out with a nice softball for everybody to answer, but one thing I told Armando is I love that this has been a very meaty conference and not just a bunch of buzzword bingo like some of the things that I've been to recently, and we'll try to keep it that way. So we'll get them comfortable with answering a question, and then we'll start to drill in a little bit. So gentlemen, the topic is preparing your organization for the big data revolution. And Jason, I'm going to start with you, and we're going to work our way down the line. So what does that term revolutionary mean to you? I mean, what are you seeing in terms of a revolution in the space that we're operating in?
Right. Well, first I would say revolution means you're doing things that you didn't do before, as opposed to just doing things better than before. So I liken this a lot to, if you remember the days of dial-up, and that's where your internet was 56K or whatever, and then you got broadband. And it wasn't just that it was faster. I mean, of course it was, but you're now doing things that you just never would have done. You never would have done downloading gigabytes of data, operating systems. It's different. Even though it was just a change in quantity, it changed things qualitatively. It was a revolution. Got the same thing going on here now. What we can do with data and the amount of data that we can deal with, fundamentally different than before. This is not just the data mining where someone discovers that men on Fridays buy diapers and beer at the same time at convenience stores. Much broader than that, much larger data sets.
Well, let's just keep it going right down the line.
Sure. So for me, I'd like to think of the revolution kind of I preface it with disruptive revolution. I really view this as this whole movement as it's really disrupting business models across a variety of different industries, including finance. And what that is it's part of it's the data and the infrastructure and the architecture and the technology and the cloud and everything that's bringing that to bear, that anybody can now spin up and start doing big data analytics very cost effectively and cheap and start new companies. Also to the side that really the value out of this new big data revolution and big data economy is the insights you glean from data, right? The data is now more valuable than the infrastructure, than the computing power you have. And that's where people are really driving new innovation, is insights they can have for customers, insights they can have for generating alpha. The whole new AI movement is all about mining data to get patterns that we've never knew were there before.
Yeah, and I would wholeheartedly agree with both of them here as well, because I think even for us at Dow Jones, we're looking at new innovative ways we can continue to provide content, to our customers, right? So we're also taking advantage of this big data revolution, as we so call it. And we see a lot of companies, even our customers, our competitors, et cetera, in order to even stay relevant, in order to stay competitive, and so forth with the rest of the industry, they need to figure out a way to actually adopt and leverage big data and content within their organization, whether it's to improve their own business, whether it's to improve their products and services they may provide to their customers. And to further add to that, even if you look at what we're doing internally, with our newsroom, right? We have a very large newsroom that creates a lot of content. And they're looking at new ways they can generate even better content, more relevant content, and so forth. And we're looking at ways we can leverage data science technology, machine learning technology, and so forth to help the newsroom out.
So before I ask the next question, we do see you, by the way. Let me ask you guys a question. How many of you are doing the majority of your research in cloud today? Come on, nobody can read your name tags. You're not divulging any big strategy secret here. Wow, that is actually shocking to me. But let's talk about cloud, because you guys have been around a while, and let's definitely get a microphone up here. But Jason, I want to talk to you. Your business existed pre-cloud wave. Like, how has the cloud changed your business?
It's changed it entirely. So yeah, we started before there was really the cloud. We bought our own hardware. We hosted our own hardware. So we had to hire people for all of this and so on. And RavenPack has this archive from year 2000 to today. When we release a new product, we need to reclassify all of that for the new event types, new entities, all the stuff that Peter mentioned. That used to take us at least 6 weeks. And when after 3 weeks of that process, we discovered a problem, we had to start again. It was very, very painful. Now we've moved to the cloud, and we can process that whole archive in a day or two, right? And we don't have to buy the hardware for it. We rent it. So the whole way of doing things is much better. But there was also a cost to this. We had to invent new technology, do new development to enable this type of stuff. And all of it means that the product that we can bring to market now is much more fresh. It's not based on research that was finished 6 weeks ago. It was based on the data that was finished just days ago.
Anybody else want to respond before we get to the audience question? How has the cloud changed your business? Because you're all from businesses that have been around pre-cloud as well.
Yeah, sure. And I'll add a little bit to that as well. I think Dow Jones has gone a pretty massive transformation as well with respect to adopting cloud infrastructure. If you look at our business, I mean, we have, again, a whole wealth of content that goes back, 125 years, right? Wall Street Journal's been around for a long time, and so forth. So we've also done a great job of moving to the cloud. In fact, over the last couple of years, we're now probably at about 70% in the cloud. And we wouldn't be able to do the things that we're doing now without that infrastructure. Very similar to what Stuart said, we have like a archive extraction solution and things of that nature. And if we ever wanted to provide to a customer more than even a year's worth of content, it took us over 2 weeks to do that per year. So if you wanted 10 years worth of content, it was 20 weeks to get that content to our customers. Now with the cloud, we're able to offer that in literally a half an hour, right, to our customers. So there's a lot of things that's opened the doors for both us and our customers to do.
I'll kind of follow up on his conversation from how we've seen it, because we're not known as a cloud player. We're an algorithms company, right? A math company. And when he asked the question about how many people are doing research in the cloud, not very many people raise their hand. And that's what we see is a lot of people are still doing research on the desktop on small data sets, but they pull it in and send it back out to the cloud. What's changed for us is the deployment model, right? I develop a model in my research team, and then the time it takes to get it from research into a productive use used to be days or weeks. You'd have to recode it for different platforms. You need to then deploy it, go through a whole build and test infrastructure process, and then get it out there. But if you look at the reality today, you can't wait days or weeks because people are shipping new services, algorithms of services in the cloud than the matter of minutes to hours, right? So we try to make it as easy for our customers to do their research on the desktop by using the cloud for the data source, and then put it back in the cloud as soon as they're done as a new service that they can then call from their clients' computers, from their computers, from wherever else. So that's it mirrors kind of what I've seen in industry. So it's kind of interesting to see that echoed throughout you guys as well.
What do you have for us?
Thank you. My question is in regards to resistance. Are you guys seeing resistance to your revolution?
That's a great question.
We get that question a lot at RavenPack because we're selling into the financial industry, and some of our clients, or would-be clients, are banks, and there's a lot of fear, uncertainty, doubt. So there's resistance on that side. It's like, is your data safe in the cloud? And is there any personally identifiable information that's out there? What if the cloud got broken into? The good news is that the answer is a good one. RavenPack is a much smaller company than, let's say, Amazon, right? So Amazon probably has hundreds of security engineers working for them to keep their systems safe, secure, and up to date. RavenPack can't possibly invest that same amount of resource. So I think there's a really good answer to that fear, uncertainty, doubt, and it's not really well-founded in, are things less secure? No, they're probably more secure.
I'd follow that up with and say the same kind of thing, is that I think the security is by far, the biggest resistance I've seen in many cases. If you would have asked me 2 to 3 years ago, are you seeing resistance? I would have said yes. I visit a lot of customers. They often ask us, do you have a cloud strategy? What are you doing on the cloud? And I ask them back the same question. What are you doing for the cloud? And they're like, oh, we're just playing around. We're just doing some research projects up there, just seeing what the technology provides. Within the last year, though, that's completely changed. Everybody I talk to says, oh, yeah, in 3 years, our entire IT infrastructure is going to be in the cloud across just about every bank I visit. So we've turned that corner. I think the resistance is no longer there. I think it's kind of, there might be some pockets left, but most of it's kind of been diminished. It's no longer a concern. Now they're more about, we got to get in the cloud because of that time productivity. I need to be there first mentality is really kind of taking over. So maybe it's not resistance now as much as fear of being late. Now they're starting to feel that they might be late, so they need to get up into the cloud and be there with everyone else.
Yeah, I would agree with both of them. I think, if you rewound, 2, 3, 4 years ago, you saw much more resistance. Now, everyone's pretty much accepted that the cloud is where they need to be, as well as where we need to be and where they need to operate. I think a lot of the security concerns have been addressed, and not only that, even beyond security, you're seeing, much more investment in terms of, infrastructure, data centers, et cetera, from the big cloud providers, right? Whether it's Amazon, Google, Microsoft, et cetera. And they also provide better resiliency, availability, and so forth. So in all ways, I think it's a win-win situation for many folks, and I think they're realizing that.
In addition to that, are you seeing resistance to the whole concept of big data being used in the financial industry, in addition to the cloud?
Sure. I mean, I'll start that off. Not really, right? I think, in fact, the probably financial industry has been one of the first adopters of big data. I mean, we use that term big data, but they've been probably doing a lot of quantitative analysis of large data sets and so forth longer than most other folks have. So if anything, they're trying to take advantage of even more data sets, right? There's all sorts of alternative data sets that are out there, even things like IoT data and so on. So if anything, they're trying to take as much as they can that they can leverage to help generate insights that are going to help their business out. So I haven't seen much resistance in that regard.
I don't know I've seen resistance as much as confusion, right? Because there's a lot of different competing technologies and platforms from, Hadoop and Apache Spark, Elastic MapReduce to GPUs and the whole deep learning and AI trend. And what I really see is confusion on which technology should I use and when, because it's not, the technology fits different problems differently, right? Deep learning is great for these massively parallel computation you can do, but running an optimization algorithm on it isn't the best use of that time on a GPU. So it's really, that's what I see from our perspective, is how we can help our clients and our customers make sense of the different technologies and when they're useful and when they're not, and how to best deploy them in the practice of developing the things that they're doing within their internal infrastructures.
So Stuart, I want to stick to that question. You mentioned GPUs. I mean, what are some of the considerations for writing a strategy to work with a specific set of infrastructure?
So it's well, there's GPUs, and I'd also counter that with kind of the MapReduce framework, right? So if you're a statistician, you want to write an equation, an algorithm, a linear regression algorithm, as an example. trying to write that in the MapReduce framework is very hard. You got to think about the structure of the data, how it's going through the mapping step, and then the reduction step. So the algorithms themselves are tailored to the platform, right? So the MapReduce is tailored to Apache, Hadoop, and Spark. On the other side is the GPUs, which they're massively parallel and scalable, but they don't work well for tightly coupled or iterative systems, right? So if I can calculate something once and then do an update, GPUs are very, very fast and efficient. The challenge with the GPU, though, on the other side is that it's got like a straw going into it. I can only put data so fast and only store so much data, but I can compute like crazy. So there's a data bandwidth issue that gets there. So when you try to write algorithms in a MapReduce framework, it becomes very customized to that platform, and I can't reuse it outside of the MapReduce framework. Same thing with the GPU, right? What we try to do with the MathWorks is abstract the algorithms, give you the machine learning capabilities that work on both platforms, and then you write the math on top. And then the variables just tell it, I'm a GPU array versus I'm a tall array that's basically an indicator of a MapReduce infrastructure. So now you can separate the math and the algorithm that you're creating from the underlying infrastructure. And then the nuances of the platform are things that we try and take care of. So that's really the challenge I see today, is using all of that technology productively across your different applications. And targeting like a GPU for deep learning, for machine learning applications, is something that you want to do for speed and performance. But you may also want to take that machine learning algorithm that you developed for the GPU and run it on the data that's much, much too big to fit on a GPU in like a Apache Spark, as an example. Excuse me. So you can take the same algorithm and run it across both. Is really what I see that the revolution in the area is, being able to separate math and data and operate across the different platforms independently.
So, Jason, I mean, you had in our call brought up some very interesting things about your sort of learning cycle as you guys migrated to the cloud. Can you kind of talk about your experience and some lessons learned in that activity?
Yeah, sure. So as I mentioned, we had our own hardware system, and then we migrated to the cloud. And the great thing about the cloud is that there's tons of options. The bad thing about the cloud is that there's tons of options. You don't know what to choose. Like I said, it's all new. So we work with Amazon, okay? But I think these lessons are the exact same if you work with Google or Microsoft. They offer various different pricing models. So when I said, oh, we can classify everything in 1 or 2 days now, that's true, but which computing resources do you use for that? Well, if you just buy everything kind of on demand and they have an on-demand price, our reclassification could cost $10,000, $15,000. That's a lot of money. If instead you use what they call like spot instances, where you basically rent them at a price, and they say, look, if someone outbids you, we'll take the machine away. But remember, our process here is one where we have a news story, we classify it. If a machine goes away, that's fine. Another one will come along and we can classify that story. No problem. Then we can classify this whole archive for maybe $2,000. When you first start in the cloud, it's hard to know about this. You also went from a world of central databases where you had like Oracle, Microsoft SQL Server, IBM DB2, and a few others. That was it. Now, if I were to try and name the amount of databases out there that you might choose, I'd use up our time. So you have to do some research. You have to figure out what's going to be best. We've initially chosen some technologies at Amazon, and then in the 2 to 3 years since we started, they've already introduced new ones, which looks like better options, so we'll be migrating again. So it's the Wild West. It's fun and exciting, and you need to spend some time to keep up with the cloud companies to understand what their technologies are, what their pricing models are, and it's really easy to fall behind, and that's the challenge.
Any additional audience questions before I move on? Yes.
I have a question relative to the topic of preparing your organization, and it really deals with the issue of cultural clash. And there was an article in Bloomberg in February, Why Data Nerds Struggle to Gain Power at Hedge Funds. And maybe if any of the panelists could address, as a 35-year veteran of the investment industry, you have lots of strong-willed, discretionary portfolio managers or fundamental managers that really have a potential to clash with data scientists or computer scientists. So how do you mitigate those potential cultural clashes.
Thani, why don't we start with you on that one?
Sure. I mean, I think we went through a similar challenge even internally ourselves at Dow Jones as we were building out a data science team. I think a lot of the way we addressed it was through some growing pains and lessons learned. But what we initially saw was these data scientists were kind of didn't really have a clear charter, right? They weren't working very closely with the business and so forth. And I think that was a major lesson learned. So now we've really morphed that team to be driven from the business folks. So really, it's where I think they need to be collaboration partners, right? So the portfolio manager, et cetera, their knowledge and experience is actually very critical to the data scientists, right? The data scientists understand things like statistical modeling, leveraging the technologies that are there to derive insights, but they may not be the domain experts, right? And so you really need to have a combination of both. And so that's where I think now combining the domain experts with the data scientists, where they now have a very clear charter, and really the domain experts driving that, right, their charter and their mission and so on, they work much better together. So I think that was one thing that we learned quite a bit, and so that's how we've kind of restructured and organized, and it's been working pretty effectively. So even if you see, for example, our data researchers, as well as our newsroom folks, they're the ones now driving their goals to the data scientists, and the data scientists are helping them achieve their goals, and they're able to validate it. There's a lot more of human interaction as part of that process that works well.
I'd like to follow up with that, because he's talking a lot about the bringing in the domain expert to help kind of solidify the direction of the data science team. I've talked with many companies and customers of ours that built data science teams, and I asked them what do they do, and they said, I don't know, we're a new data science team. We're just tasked to go figure out how we can use big data, AI, machine learning to do something, right? The teams that I've seen that have been successful and actually been able to achieve good results for the organization have not only brought in the domain expert, but the domain expert actually defines a business problem for them in a means that they can then gel around that and try and address the problem. So when you have a business problem that you're trying to address, that's really when the data science is going to bring the value, because now they're trying to figure out that particular unique scenario, but also because they're bringing a variety of big data and other data that they might not have seen before, they might see other tangential problems after that or alongside that and kind of build and get a steamroll effect of not only did they solve that problem, but now we have something for this one because we can reuse this architecture over here for that one. And that's when I've seen it to be successful. So it's really kind of giving them a vision and a business objective and having them drive towards that'll make them successful. And I think in terms of the portfolio manager, he's the domain expert. He knows he's got lots of problems he'd like to see solved. I think he could really leverage data scientists much like he would a quantitative analyst. Just empower him to help solve a particular problem that he has on the top of his mind.
So let me answer the question by asking you guys some questions, just to kind of play along with you guys here for a minute, if you'll indulge me. How many of you started at a firm and spent your first, let's call it 6 months, just getting the data quality to the point where you were able to demonstrate any value? Cleansing, scrubbing. Okay, there's a few hands there. How many of you started at a company that said they wanted you to be a data scientist, but they didn't have the infrastructure or the organizational support in place to be able to get you what you needed to do your job? Okay, a few more hands like that. So these are some of the challenges that we've seen. I don't know if you've seen others.
And I think to that question, I would say that I'm an engineer. I've always been an engineer. So, and I love engineering. I think engineers, we build things. But if you look at like civil engineering, you've got architects that design buildings and design bridges, and then the engineers that come in and help build them. Those two people have to work together. Engineers probably don't design very beautiful bridges. Okay, engineers probably also don't design very interesting portfolio strategies. But if you need to iterate over petabytes of data, you probably don't want to do that. You probably want the engineer. So it's got to be teamwork, and both sides have to see and respect each other. If anyone has a chip on their shoulder that they know it all, it probably wouldn't work, right?
Yeah, and I'll add to that a little bit too, in terms of some of the challenges we've seen as we've built out our data science practice as well, which is data engineering, I think, is really critical. It's not just the data scientists, right? Especially when you're dealing with lots of data. If the data scientists are going to be effective, you need to get them the data in a consumable way where they can actually do their data science, right? So if we've even seen our data science team, it's morphed quite a bit. we have less data scientists and actually more data engineers. I think there's a statistic out there, something like, in this field or in the big data field, you spend probably 80% of your time doing data prep, data cleansing, et cetera, before you even get it to a state where you can actually do your data science. So that's something that we've changed in adopting now data engineers that can help, leverage technologies like MapReduce, Hadoop, or technologies like GPU, depending on the use case. So
I'm totally putting in staffing requests for those.
I mean, I'll follow that with, having the data in the right format is critical, but also being able to access it iteratively, because data analysis, data analytics, it's all about iteratively looking at the data, creating a model, refining the model, updating the model, looking at different factors, visualizing it. That's an iterative process, and if you can't get the data in, you're kind of stuck, and it takes a lot of time away. If I have to reformat my data every time I want to create a plot, that breaks the flow, and that breaks the speediness that you can do on actually driving insight. So then rather than creating the best model, you get a model, and then you're like, this is good enough because I can't deal with the pain of copying and pasting and manipulating data. So that's the key thing, is to make sure that you have a way to not only bring it in structured, but be able to reformat it on the fly to different formats. And I think a good example of that is if you look at like fraud detection, a lot of fraud detection applications are using network analysis or graph theory on entity relationships and trying to analyze the relationships that happen. Graph databases are awesome for that. They're very effective and fast to do that kind of queries and searches interactively. Try to do the same thing on a SQL-based relational database. I think you'll scream and run out of this room and never come back to the data science community if you try. It's very hard when it's formatted that way. So you need to be able to take it in a structured format and put it in different types of structured formats and do that fast and efficiently so that you can enable the innovation throughout your organization.
Any other questions from the audience? These are great questions, by the way. Thank you for engaging. Yes, we have one over here.
Could you talk a little bit about scaling the organization as more and more data sets enter the enterprise? And how do you add to the team? What technology do you need? What level of IT do you need? And how much of an investment do you have to make to scale?
Maybe I'll start. I think leveraging the cloud and the cloud players is a really the way to go. Amazon, Google, and Microsoft, they all offer a lot of services. So it used to be that you're like, oh, I just said there's like 1,000 different databases you might choose. Well, you don't need to hire necessarily a database administrator for, let's say, MongoDB that you chose to use. Instead, there's probably a service offered by your cloud provider that you go to a console, you click on things, and you start up a database. And how do you load it? Oh, well, they have a service that lets you put a file in Amazon on S3 and copy that into your database. And so there's a lot of tools there that allow what you would call a full stack engineer, someone who is comfortable building software systems, to deal with these tools without having to become an expert or without your organization having to hire specific people. Once you choose something and you say, we're all in on Elasticsearch, then you may decide, hey, let's staff up some people here so that we understand this more deeply than the introductory stuff that we're getting through our cloud provider.
I mean, just to answer that question, last week, it's no plug to us because it's not from us or for us, but Google announced direct connect capability inside the same data center that CME Group is in. And that was really customer driven. And the customers were driving that for scale because they wanted access to the infrastructure, to the TensorFlow capabilities, to the TPUs. We talk about GPUs. Google's coming out with their own. But that's part of sort of an en masse scale exercise on behalf of some firms in Chicago. So, anybody else want to chime in?
I'd follow. I mean, you asked about scaling the teams as well. So I'll kind of start with the infrastructure and then move to the teams. So on the infrastructure side, I think the cloud is the only way to do it. It's the only way to spin things up and bring things down in a cost-effective way. He mentioned spot instances before, which are great, really cheap resource, but they can be taken away. On demand allows you to get up there for fairly decent prices, but you can also do reserved capacity, so you can actually maximize how you use the different type of instances cost-wise. So you can do some cost optimization in the cloud. You can't do that with your own systems if you're buying your own hardware. You're stuck with the infrastructure cost as it is. But so what we see from that is not only do you need to be able to access and use the cloud, but you need to build a team that can figure out how to use the technology, right? So you need a system architect is one person you need on the team so that he can help you identify all the cloud components you need, the data, the compute, the networking that you might need. The system architect will be great for that. You'll need a kind of a data engineer to really figure out what databases to put your data in, what style, what format, the ETL operations you need to do to get your data into these different vendors as well. And then you need a data scientist, and then probably a business, not necessarily a domain expert is what I would say. You need a domain expert, and then also kind of the business champion, the person who's really driving the business problem. Those are at least 5 people you need to kind of start a team, and then from there you'd expand it out based upon where the team's going. If you're in the cloud, you might only need 1 system architect, 2 data engineers, and 3 or 4 data scientists working under a portfolio manager or the business domain expert. So depending upon the nuances of your business, those teams would mix and match based upon what is the value that you're generating out of this infrastructure. But it's at least about a team to start of 5. To really think about it. It's hard to get all of those skills in 1 or 2 to 3 people.
Yeah, I mean, I would echo that. I think we were actually, a little bit premature in that we built the team without prepping the data first. So we learned from that, because I think that's step 1 is getting the data in an accessible format and an accessible location and so forth. And that's really the cloud, right? So we had our data in various different databases, in our data centers across different technologies, and it was very, very challenging until we got all that data into a more centralized place, more accessible place. We were leveraging Google's cloud infrastructure to make that accessible. And then, like you said, I think data engineers were a key part of that strategy in prepping the data. And then once you have that, then you start scaling out with data scientists and the business to set your actual business objectives.
Any other questions from the audience? Got about 12 minutes left. Okay. I want to talk about something that's about probably the least sexy portion of this topic, and that's content licensing. So Thani, I want to come to you. So how does content licensing play into all of this?
Yeah, it's a great question. I mean, we've been tackling that, as Dow Jones, as a content provider for a very long time, right? And from a publisher's perspective, the licensing game has really changed, especially even with folks like the Googles and the Apples entering into the news and content world as well. And if you looked at our licensing traditionally, it's always been for redistribution to our customers for the purposes of doing research. But mostly reading consumption, human readers, consuming that content. Now, with the advent of, AI, machine learning, text mining, natural language processing, et cetera, the licensing rights are changing. We as publishers and content creators are also looking at ways now to monetize on that, right? And to establish the proper rights so that people can actually do that type of work on top of content. So we've been, our content licensing team actually is working pretty aggressively with our other providers that, where we aggregate a bunch of content to ensure that we have those types of licensing rights before we can redistribute it to our customers. So now, content providers and creators are looking at, okay, we should be thinking about, licensing rights around text mining, natural language processing, creating derived data sets, how long you can even store that content as part of that process and so forth. So it's an evolving, thing at the moment. It's very, very new to a lot of these content creators and providers. So, we'll probably see that continue to evolve over the next couple of years.
Does content licensing affect your business at all?
At RavenPack, yes, it does. I mean, we're mostly interested in selling derived data, so we need to work with content providers to make sure the licenses allow derived data, and hopefully this is good for the content provider as well. Their content in original form has value extracted from it. So we extract the value, we get rewarded for that, and the original content, of course, is rewarded for providing those inputs. So it's an evolution, and I think what Thani said really makes sense.
So we're actually responsible for some of the content licensing, and if any of you are doing a startup that does like digital rights management on data that'll allow us to like rent data in a protected way, like hand me your card on the way out.
Absolutely.
It's definitely an area we're trying to get to, and we're kind of counting on Moore's Law to be ready for it when we are. So, speaking of being ready, what's next? And I'll just open this up to any of you. I mean, what are people not planning for that they should be thinking about?
That's a great question, and it's probably the most difficult one, is always to predict the future, right? But I like to think of it as an engineer, and I'm being really lucky at RavenPack is part of that is, well, what can we invent? And then I'll have invented the future. Great. So the cloud is not only, and big data has not only enabled us to say, solve our internal problems, take a 6-week problem and convert it to a day problem, but it allows RavenPack to offer brand new services. So hopefully this type of stuff makes our customers have an easier life. You don't need to invest yourself as much in learning and becoming experts at big data technologies, but there'll be vendors, RavenPack, and there's going to be many others that come up and start providing you services that are novel. And you're going to be interested in those, because instead of having to deal with raw data and having to massage things, there's going to be vendors that are going to want to show you, hey, here's not just raw data that you can extract value from, here's valuable data you can trade with it. That's the goal.
Yes. So I'd say from the perspective that I see, there's a couple trends that really drive maybe where technology and innovation will take it. We're seeing a lot of push to streaming and real-time algorithms and data. So not only is the data from the Internet of Things world coming at you either all the time or fast, but your algorithms also have to be able to adjust and adapt to that. And we're seeing it across the board from risk management teams that used to generate nightly reports. They now want to have instant, on-demand risk reporting, right? So they want real-time risk reporting. And how you do that when you're going from a batch processing world into a real-time streaming world is different. So algorithms that we use today are going to need to be modified so that they can incrementally update their parameters as new data comes around. I think the area of Bayesian statistics and Bayesian machine learning is an interesting area that's evolving for that, because it's really good at updating based upon new information coming into the system. It's probably not the only thing. Like deep learning just kind of exploded. Neural nets have been around for 20, 30 years, and suddenly we got computing power big enough to do these very deep nets, and that took off. So it's hard to say which algorithm, which technology will, but I think you're going to see more real-time computing, more stream processing, really driving kind of the engines behind the infrastructure that you'll be using for your businesses in the near future, if you're not already starting to move there in some ways.
Yeah, and I'll add to that too in terms of some of the trends we've seen across the industry. I think one is like I'm starting to see, for example, Google announced during their cloud summit, back in March, right, which was a big message for them, was data science as a service and the democratization of data science. So I think you're going to see a lot more of that from a lot of these technology vendors and companies and cloud providers. So again, even with what MathWorks is doing, right, in terms of abstracting a lot of that, so that you can really focus on your business goals and your mission and the derived data sets and insights that you're looking for, right, to make all that stuff much easier, so you don't have to worry about the infrastructure, worry about the technologies and so forth. So I think we're seeing a lot more of that. It's really interesting also, what Google's done with their acquisition of Kaggle. I think I don't know if you guys are familiar with Kaggle, but it's basically a data science community that can go and solve a problem for you. And so it'd be interesting to see where they go with that. So that's where I think there's this notion of data science as a service that may be emerging. And even things like AI, services and AI as a service. I'm seeing a lot of companies pop up, that are specializing in AI. I mean, RavenPack is, a good example even of some of that in various verticals and industries, right? So I think we're going to see more and more of those things, which means a lot more data to work with. So it should be an interesting, I think, next several years in this space.
Any other questions? Yes, we've got one down front.
My question was to follow up on the next big thing. Can you guys comment a little bit on crypto?
Cryptography?
Yeah, cryptocurrency.
Oh, cryptocurrencies.
Yeah. And blockchain.
So blockchain is the technology that underlies cryptocurrencies. You probably are familiar with this. And I think it's huge. I think it's going to revolutionize things. Until now, you needed a government to establish a currency, and now you don't. That's pretty big. Companies will have their own currencies. They already do. And some of these are going to be really successful. So there can be commerce without a government to back it up. Really interesting. The technology is basically one about trust. Basically, you trust your government, and that's why the currency has value. Well, the theory is that you don't trust anybody, so let's develop a technology that allows you to not trust anybody and still participate. It's a little bit like escrow, right? Mutual distrusting parties. But this is in the large. And right now the problems with it are, if you look at Bitcoin, the database is, I don't even remember how many gigabytes, and it keeps growing and growing and growing. That's probably a problem that that community needs to solve. And how will it solve it? Well, it's big data, right? And cloud computing and things like this. So it's going to be huge, I think.
I agree with the blockchain behind the Bitcoin and everything. I think that's going to revolutionize just asset management in general and how you deal with physical things in the world that we still have to sign paperwork or exchange stock certificates, your deed to your house. All those things will become digital and instantly be able to do a transaction. Imagine closing on your house and never having to deal with paperwork. It would be awesome. So it's like, if you heard Bill Gates and the paperless economy that he always envisioned, it might actually become true because of this technology that allows us to take the things that we have to do, keep records of, because it's the only way to keep a single truth. Now there's a single truth in the digital space. And it might actually disrupt the content management as well, because think of if you could take content, wrap it in a blockchain, and only allow that person to use it. That's one way the content management might actually be impacted by the same technology behind the Bitcoin.
Yeah, I mean, and I would agree with both of them. And I think, we're looking at ways we could potentially leverage, blockchain from a content rights and management perspective, right? So, we talked about digital rights management. It could be a great way to facilitate that. I mean, there's a lot of application for blockchain, right? I think it's still evolving though. And now with, technologies like the cloud out there and so forth, we have the ability to be able to potentially support it. With a lot of different, in a lot of different sectors and industries. So I'm intrigued to see how it's going to evolve. But I think a key part of it, though, is for blockchain to be successful, it's that peer-to-peer trust. It's the broader network, right? We don't want it to be privatized, in my mind at least, and managed, by just a bank or a set of banks. That's my perspective on it. But I think there's more value to be gained by letting it be more of a established peer-to-peer trust model.
So obviously, CME Group, it's public. We have, we're exploring this with our Royal Mint Gold contract. We have a ventures fund at CME Group, and the more interesting investments that we're making, and certainly there are some in the crypto space, but the one, my favorite in the context of this space that we haven't talked about on the panel is a company called Privitar. Yeah. And what's interesting about them or an Ananos or somebody like that is one of the things we haven't talked about is PII and GDPR. And if you don't know those acronyms, you will. Being able to kind of unlock data from the constraints of privacy, without having somebody steal it from you a la Equifax. But that to me is a more applicable sort of emerging set of technology than maybe some of the blockchain efforts in the context of these discussions. So, any other questions? We've got a minute and a half left. One more over here.
If you are concerned about reputational risk or compliance issues, and you're constantly generating alpha or excess alpha as a result of your use of alternative data sources, how do you make sure that the regulators or Bill Galvin or Galvin from Massachusetts or someone doesn't come after an asset manager saying, wait a minute, this looks like expert networks. This doesn't look like genuine alternative data where you generate real alpha. That is, you're trading on inside information. It's happened already. I know of one firm that had action brought against them where it was an allegation that they were trading on inside information, when in fact they were using the mosaic theory, right? Put together all this information to come up with a portfolio. But any ways to protect your reputation or compliance concerns?
I think big data can be used to help manage compliance, right? It's one of the things that RavenPack data is currently being used for. You can easily correlate what events are in the news with accurate timestamps and compare that to when conversations occur. One of the things that RavenPack is actively pursuing is not just analyzing public content, but private content. So establish a relationship with a hedge fund, a bank, analyze privately their content using cloud infrastructure and a secure network, and then you have this audit trail of when conversations took place about things. So it doesn't solve the problem of insider trading, but it can help manage compliance. Is this an example of it, or can you prove it wasn't?
Great. Well, that's our time. I'd like to thank both the audience for engaging and our panelists. And
Thank you.
Thank you. Appreciate it.
Thanks, Adam.
This is RavenPack.